Okay, so we are going to look at proving that triangles are similar. Now, we already went through the angle-angle similar postulate back in lesson 2. Now we're going to look at side-side-side similarity theorem and side-angle-side similarity theorem. Now, to prove that two triangles are similar using the side-side-side similarity theorem, we need to prove that all three proportions are the same in both triangles. So if we look here at the example, we have triangle ABC is similar to triangle PQR. Now, to prove that both of these triangles are similar, all of their sides need to be proportionate. So AB over PQ needs to be similar to BC over QR, which needs to be equal to CA over RP. And if all of those sides are proportionate, then we could say that triangle ABC is proportionate to triangle PQR. So let's look at example 1 over here. It says, which of the following three triangles are similar? So if we look here at the first triangle, we've got A, B, C, and they're color-coded for you, is congruent to D, E, F. So we're going to go ahead and we're going to first take AB is congruent to ED. So I went ahead and put 6 over 4. So 6 over 4 is similar to 9 over 6, which is similar to 12 over 8. Okay, so let's go ahead and reduce it. We can reduce 6 and 4 by 2, which gives us 3 over 2, 9 and 6 by 3, which gives us 3 over 2, and then 12 and 8 by 4, which also gives us 3 over 2. So we can now say that triangle ABC and triangle DEF are similar because they are similar because of this side-side-side similarity theorem, because their ratios are all the same. Now let's go over here and look at triangle DEF and GHJ. So we're also, again, they're color-coded for you. So let's go ahead and do 4 over 6 is congruent to 8 over 14, which is congruent to 6 over 10. So 4 over 6, we can go ahead and reduce that by 2, which is 2 and 3. We can reduce 8 and 14 by 2, which gives us 4 and 7, and then 6 and 10 by 2, which gives us 3 and 5. If you notice, their proportions are not congruent. Therefore, these triangles cannot be similar. Okay? Now, go ahead and do example number 2 on your own. And once you're finished with that, we can go over here to side-angle-side similarity theorem. Now, if an angle of one triangle is congruent to another angle of the second triangle, and the lengths of the sides, including the angles, are proportionate, then these triangles are similar. So up here we could prove that these two triangles were similar because of the side-side-side similarity theorem. Now we're going to prove based on the side-angle-side similarity theorem. So we have to have at least one angle of the same that are the same, and then two corresponding sides that are proportionate. So here we have triangle XYZ, so triangle XYZ, or XYZ is similar to MNP. So we would need to prove then that angle X was congruent to angle M, and then that side ZX over side PM is equal to XY over XM. And if they're proportionate, then we could say that these two triangles were similar based on the side-angle-side similarity theorem. So let's do an actual example. So example 3 says, use the given lengths to prove that triangle RST is similar to triangle PSQ. So here we've got triangle RST, which is our big one, and then we've got triangle PSQ, which is our smaller one. So I went ahead and I actually just redrew them. So here I've got SPQ and SRT. Now, they both share angle S, so we can say that angle S, these two angles are congruent. And now we need to see if our corresponding sides are proportionate, then we could say that these two triangles are similar based off of the side-angle-side similarity theorem. So let's look. We've got PS And we're going to put that over the same side on the other triangle, which is SR. So 4 over 16 is congruent to 5 over 20. Now let's see. Divide each by 4, which gives us 1 over 4, and divide each of these by 5, which gives us 1 over 4. So their sides are proportionate. They've got two angles that are congruent. So we could say that these two triangles are similar based off of the side angle side similarity postulate. So go ahead and do example number 4 on your own.